Today we're going to be looking at two problems. The first one is number 2 from section A. The problem reads, radical x plus 7 minus x equals 1. I will now show you which one I'm referring to on the iPad. Right away when we look at this problem, we know that we have to isolate the radical. We do this by taking the negative x and putting it on the right side of the equation. Once we do that, we have to get rid of the radical so we can continue solving. We do this by squaring both sides. Remember that when we square the right side, we're not distributing the exponent. Okay, so it's not going to be x squared plus 1. It's going to be x plus 1 times x plus 1. Now the problem reads x plus 7 equals x plus 1 times x plus 1. On the right side, we have to use FOIL, which stands for first, outer, inner, and last. Once we do that, we get x plus 7 equals x squared plus x plus 1. We now have to combine these two like terms to get x squared plus 2x plus 1. Now, to make this quadratic, we have to take this x plus 7, move that over here, so that this could be set equal to 0 in order to make the equation officially quadratic. Once we do that, we get x squared plus x minus 6 equals 0. Now that the equation is quadratic, we can find the solutions. Since this can factor, we get the solutions x plus 3 and x minus 2. We set those equal to 0 to get negative 3 and 2. Now that we have our answers, we can check these in the equation to make sure we have no extraneous roots. Remember to plug back into the original equation. And we're going to check negative 3 and 2. For negative 3, it's going to be negative 3 plus 7 minus a minus 3 equals 1. That simplifies to radical 4 plus 3 equals 1. Since 5 does not equal 1, negative 3 is an extraneous root. Once we check 2 in there, we get 2 plus 7 minus 2 equals 1. That radical 9 is going to simplify to a 3. 3 minus 2 equals 1. 1 equals 1. Since we already had one extraneous root and this answer is correct, we're left with the only answer as x equaling 2. Taking a first glance at this problem, we notice that it's a lighthouse problem, which means it's going to encompass right triangles and SOHCAHTOA. We have two angles with elevations, which means there's going to be two triangles and two variables. The problem also says it's 148 feet high, so we're going to put 148 feet over here. To start off, we're going to solve for y using our first angle of elevation over here. We set our angle of elevation equal to 148 over y. We do this using SOHCAHTOA. Adjacent and opposite over adjacent. We need to isolate y, but when we do that, we end up getting 148 divided by tan 43 degrees 19 minutes. In our calculators, we get an answer. We round that to 157. Moving on in the problem, we're going to solve for x now. But don't forget that we need to write it as x plus y, not just x. We set our angle of elevation equal to 148 over our variables, again using SOHCAHTOA. We isolate our variables, and yet again we get 148 over our angle of elevation. We put this in the calculator, and we get 272.2, which can be rounded to 272. We subtract that from 157. We get 115.2, which could be rounded to 115. That's going to do it for the problem. Bye.